In this video, we will be talking about the power series. So if you guys don't already know, the power series is basically kind of like the ratio test, but with an x, and you have to find a radius of convergence and the interval of convergence. So I'm gonna show y'all how to do this. So here we have the problem. And already off the bat, it looks similar to the ratio test. Like you got the n factorial here, the exclamation point basically. And yeah, so first of all, we're going to rewrite this into an. And we're going to write the an plus 1. And we're going to distribute the exponents. For the second step, we got to plug in our equation. You got to do an plus 1 over an, the absolute values. And when you're dividing by an, you can just multiply the reciprocal at this point if you have a partial fraction of it. So our an was this number, so we can just multiply the reciprocal of that. So we can eliminate stuff. So we got 3n. We can eliminate 3n. We can eliminate x n to the power of n, and we can eliminate n factorial. So we have this, and we are left with 3x over n plus 1. And now we gotta take the absolute value of it, but this will just be the same since there's no negative here, so you can leave it like that. Oh yeah, but you have to, for the absolute value, when you use an x, you have to put the absolute value for, because whenever there's an x, or whenever you're doing a power series, you're gonna have to put the absolute value of x, but not the n plus 1 or any other number. Whenever there's an x, you have to do it. So our third step is to take the limit now, like how we did in the ratio test. But in this case, we have to take out the x or whatever is associated with the x. So in this case, it's 3x. So we can take out the absolute value of 3x, and we have our limits. So this would just be 1 over n plus 1. And now we can do our basic limit stuff. You know, we got to do the, whenever we do the limits, we can do over n. So we can do 1 over n over n plus 1 over n. This will lead to 0, 1 plus 0, and that will lead to 0 overall. And when we get 0, like the limit equals to 0, we automatically know that the radius of convergence is equal to positive infinity, and the interval of convergence is equal to negative infinity and positive infinity. So when you're doing the power series, you're gonna have to find the radius convergence and the interval convergence. And when the series or the problem, when you do the limit, when you take the limit and you get 0, right? Then it, for every problem you get 0, it will be, the radius will be infinity, and the intervals will be negative infinity and infinity. So it converges for all real numbers. But this only works for 0. So this is the final answer for this problem. But let me show you another example in which the radius and interval of convergence is different. Alright, so we have another problem here. So our first step is to rewrite this as an. Second step is we got to do the an plus 1, so whenever there's an n, we got to plus 1. We can distribute the exponents. So an plus 1 over an, absolute value. So this will be so we got negative 1 to the power of n. We can eliminate that since we have both sides. We can eliminate x to the power of n. We can eliminate 5 to the power of n. And we got right here. What we got left is, so this will be absolute value of x over 5. Now, final step is to take the limit, right? And we gotta take out the x variable out of the limit, so this could be simple. So it'll be 1 over 5. And this was different than the previous question, so now we have to, it's not 0, right? So now we have to do this, right? So whenever we have an x, right, we have to, it has to be less than 1. So, but the number here, or our final answer, or not our final answer, but our number here, when we do all the problems and we left with the answer, we would have to combine with x. So technically we're kind of multiplying by x. So this will be like you're multiplying it, right? So we're multiplying by 5, right? To get rid of the 1 over 5, right? So x will be less than 5, and that would be the r. So the r is, or the radius of convergence is 5. And what about our interval convergence? In our interval convergence, whenever we have, whenever you see here, whenever you get the number, right? When you multiply it together with x, right? So we have to multiply by the, like the opposite. So the 1 over 5 opposite is 5, right? So we can plug in negative 5 and 5 because if we do that, so if you plug in negative 5 here, it'll be 5. And once you plug it when we multiply with 1 over 5, it will be 1, right? And we plug in 5 to x, we can multiply with 1 over 5, it will be 1. So basically our interval convergence, it has to be equal to 1. So this will be negative 5 and 5. And just so you know, our interval convergence, we have to, it's basically just finding what number that will be equal to 1. And that's pretty much it for the interval convergence. And this is the final answer for this type of question. So let's take a look at this question. So here we have a lot of stuff going on, but we're gonna do our basic stuff. We gotta rewrite it to an. So we gotta rewrite this. We gotta do n plus 1. So whenever there's a n, we got a plus 1. And we can distribute this more further, so this will be simpler like that. And then second step, so an plus 1. It's real quick. So multiply the reciprocal of an because that's technically the same as dividing. We can eliminate -1 to the power of n. We can eliminate x minus 4 to the power of n. We can eliminate 2 to the power of n. And we got all our stuff we need, so we will be left with -1 times n plus 1 times x minus 4 and times 2 times n. And now we gotta do our final step. So, oh yeah, we gotta put the absolute value for each one. So absolute value could eliminate, let's say we got 1, we got n plus 1, and we got the absolute value of x minus 4, right? We got 2n. Okay, when we do the limit, we can take out the x minus 4, right? And we will be left with n plus 1 over 2n. If we have an n, we can divide by the greatest denominator exponent, right? So the highest exponent in the denominator is n to the power 1, so we can do n divided by n, 2n over n. This will be left with 1 plus 0 and 2. We have to make this like less than 1, right? The absolute value of the x minus 4 less than 1. So we can bring the 2 over to the x minus 4. But in this situation, it will be just x minus 4 absolute value over 2 because we have to make it less than 1, right? So we can just bring this over here. We don't have to multiply it because we're not doing that right now. But yeah, we got to do this. So let's be less than 1. So what value of x would this whole thing be equal to 1? So we can plug in 2. We can plug in 2 for x, right? This would be 1, right? So that we got x equals to 2, right? And we can plug in 6. 6 minus 4 is 2. It'll be equal to 1. So we can have x equals 6. Convergence is 2 to 6. And our radius of convergence, let's see, we got x minus 4 2 times 1. We can bring the 2, multiply the 2 to get rid of it. So this would be less than 2, right? And this here, that's going to be our radius of convergence. So that'll be equal to 2. So our radius of convergence is 2, and our interval of convergence is 2 and 6. So this is the final answer.